Welcome back for this episode 7 of the amazing Refactor series. In the last episode, we got to a point where we were starting to change the architecture of our little maze drawing program. In this episode, we're going to continue the architectural change, shifting more of the functions out into their own classes. The way we're approaching those architectural changes are in line with solid principles. Mostly, we're here adhering to the single responsibility principle, making sure that all the classes are only going to change for one particular reason, i.e. context. So everything to do with movement is in one class, everything to do with the actual structure of the maze is in another. That level of segregation makes the code easier to maintain and should help us going forwards. In this first part, we're just going to continue that extracting of functions. Exactly the same as we did in the last episode, so I'll go through the first one quite slowly and then we'll move into speeding this video up because it could get quite tedious. Obviously I'll stop as soon as we get to something that's more interesting.
The first job is to extract some more functions into their own class. This time I'm going to look at the things that are dealing with the blocks we have visited. Once I've deliberated long and hard over which functions I'm going to extract, and making sure that there doesn't appear to be any errors in what I'm doing. Changing the isolation level of those as part of the extraction to make them public, and making sure they're in their own file. I'm going to call this the position history functions.
Once we've got them out into a new class, there's no reason why we can't make them a little more easy to read and try and get them all to expression body because that looks nice. Well, it does in my opinion anyway.
Now I've extracted those functions out, we can make this class static, using the this keyword to declare the first variable as being the type we are going to extend, and using the refactor tools to make sure that iMaze, the state variable, is the first parameter of the function. These can then, where possible, be made into expression body. Also making the local invocations to extension invocation as well. So it should make the code read slightly easier.
We're also refactoring these functions down further into smaller functions.
Start off by pulling out these 3 lines into their own function and calling that get new history. That's made it slightly tidier. We can now edit the set visited function by pulling this in line. We can then tackle these 4 lines that now exist. There's not a huge amount we can do about the array, so we'll just put that back to how it was. But we can pull the calculate position for history variable in line as the ordinal parameter on the array. So let's do that now. That's probably as much as I'm going to do at this point. We might come back and visit this later. and just run the test to make sure we haven't broken anything, and we look to be all good. Moving back to the maze main class highlights that there are actually some functions we should have pulled out, particularly where we've got these set block to left visited. So these functions should actually be inside our position history functions class, but what I'm going to do is pull them out as part of a new class and then shuffle them across, because once we've made them into extension methods, it doesn't really matter where their location is as long as the library where the extension is referenced, so it will make it slightly easier to shuffle them. So I'm going to cut and paste those functions that should actually be in this class out. Make those public. Making them into extension methods by adding the this keyword. And then making them into expression body. So at the moment, none of those are referenced by anything. We're going to sort that out, moving back to the maze. We can change that one. Oh, no, that's actually one that is inside the new state functions. So that needs to go back. That's not dealt with that as an extension method as yet. Just sorting out the fact that I have forgotten to set the isolation level of those to be public. So we'll just shuffle the last couple to make them into extension invocation, which resolves the compilation error. We've got the odd function still sat with the wrong isolation level. We can sort those out as well. Now this also points out that these are in the wrong place. In fact, they need to go into the new state functions class. So we'll do a bit of cut and paste and put them in the right place. Again, turning these into extension methods, making the class static, making the local declarations also use the extension invocation, just because it looks a little tidier. Bring that in line to expression body, and the same again.
So generally speaking, as I'm going through this, I'm moving things to be fairly small functions that I can have as an expression body. What I'm trying to get is a functional pipeline where we can take the output of one function and pass it into the input of the next, allowing us to have a pipeline of actions that make sense.
This is an example where we can make this into a functional pipeline. Now we can see the wood for the trees. It's become obvious that we should have moved these functions out into the position history functions class at the same time as everything else. So we're going to cut and paste them in and fix all the problems that creates. In hindsight, it might have been better to take a little more care about which functions we were pulling out in the first place, but that's not always as obvious as you might think, and I quite often do miss functions here and there. The important thing is that you know how to correct those errors and get it all working as you expect. What does, however, make this easier is the fact we're moving them to be extension methods. Because extension methods, it doesn't really matter where they are as long as they're referenced within the class that's using them. We can actually transition the code relatively easily just by shifting the parameter to the front and adding a dot. And you'll see me do that as we find the errors this has created in just a moment. It's also a good idea when adding functions like this that you go through everything else that you pulled out initially to make sure that the isolation levels are still correct, as you may have actually pulled out a function that was the only thing calling the public method you had transitioned previously, and therefore that can move to be private. So it's just a simple matter of going through each of the functions as you're changing the code to make sure that all the references are actually external where they're public, and if they're not, make them private. So, to correct these errors, as I mentioned before, it should be relatively simple. By moving the parameter into the context position, meaning that's the thing we are using the extension method on, quickly sorts out all these compilation errors. It can be tempting to use search and replace in these scenarios, but in my experience that tends to cause more problems than it in fact solves. All the code at the start to initialize our maze internal state can be refactored down into some much smaller functions. But the first thing is to work out what's the best thing to start with and how much of this should we pull out in one chunk. What I'm actually going to start with is a little piece that creates the entrance to the maze. Now we've extracted this out, there's an opportunity to make the pieces of code that create the new row and the new maze separate functions. So first thing we're going to do is pull out both lines of code and make those into a function that creates a maze with a first line which includes the entrance. We can then separately extract another function that just creates a new row that includes the entrance. We can then pull that down into the append function parameter, and we've got it into a single link query line. Now we've pulled out a couple of new classes, we can do some more, and we'll do that speeded up. A lot of this is actually being able to see the wood for the trees, so you'll actually find you'll get quicker as you move through the code. As more gets extracted, it starts to find its place.
Been a long time without you. Been a long time without love. Everything reminds me of you, but everything is not enough. Really hard to by the ocean, among all those white hot sands, where every sunrise is just for you. So come along and take my hand.
So we've done a fairly big chunk of refactoring there, and we've got to running the unit tests again. But they're failing. You'll notice in a minute that I went down quite a bit of a rabbit hole that I didn't record, unfortunately. But the actual solution to why things were failing was actually just a single line of code that was missing after rearranging some of the logic. So here's that line of code magically appearing, and all the unit tests having passed. So that concludes this episode 7 of the Amazing Refactor, but we're still not quite finished. There are still some elements that don't quite sit right, and we can definitely do better. In episode 8, join me to continue the journey. Hopefully, by the end of that episode, we'll have completed there or thereabouts the entirety of the refactor. This should result in us having an application that is maintainable going forwards. And because we've spent the time to decouple it, introduce things like dependency injection fairly early on in our refactor, we can technically look at doing things like re-implementing the output display to do something that's a little more modern rather than just text. But that's definitely something for beyond the next episode.